Hello again. In this lesson we'll talk about using variables in C#, what they are, how to declare them, and I'll explain what data types are and how they fit into the picture, how to convert values from one data type into another, and so on. And then we're going to talk about the difference between statements and expressions and look at the different types of each. So let's get started right now. And we'll start by talking about one of the building blocks of code, variables. If you remember back to high school algebra, you might remember a problem that looked a little bit like this. X equals 3, y equals x plus 7, so what does y equal? Now in this problem we can see that there's two variables, x and y. Since x is assigned to the value of 3, we can easily see that y would then have to equal 10. And at their essence, these variables simply represent some value. You can think of them as like buckets that contain a value or represent a value. In computer terms, a variable is a spot or a space that's allocated in the computer's memory to store some value. And we as programmers can reference the value that's in the computer's memory by using the name of the variable that we give it. Now also back in algebra, we only worked with numerical values, but variables in the programming world can contain strings and dates and big numbers and small numbers and much more. In order to know how big or small to make that bucket in the computer's memory, we have to declare the variable in order to tell the computer what size of information we expect to store in there. So let's get started with this lesson by going and creating a new project so we can write some sample code. We'll call this project Lesson 04, and we'll select OK. And what we'll do, just for fun, is we'll put a single button on our form, double click it so we can get to the code view, and we'll spend the majority of our time here. Declaring a variable is pretty straightforward. All you need to do is, first of all, define what data type that we'll use. In this case, we'll use the data type of string. We'll talk about data types in just a moment. And then give the variable a name. In this case, we'll call this my string variable. And we can name it anything that we want to name it as long as it doesn't conflict with the exact spelling of an existing variable or some object within the .NET framework or something along those lines. You don't have to remember what those are because Visual C# 2005 Express Edition will tell you if you used a name that's already in use by some other object or in use by Visual C# or the .NET framework. So don't worry about that for now. We can also create another version of a variable, and that is called an initialize variable, where you're basically taking two steps in one line of code. So in this case, everything starts off the same, but then we're also going to assign it some value right away. In this case, I've just assigned this to an empty string, but we could assign this to Bob or some other string that we wanted to put in here by default. So basically in that second line of code, we're defining how big the bucket should be by saying it should be a string, and then immediately filling up the bucket with some value. Let me type a couple more lines of code. So in the first two lines of code, we created two variables and each of their types are strings. Strings can contain alphanumeric characters, both numbers and letters, and any other key combination on your keyboard. However, if we need variables that can be used for mathematical equations or to use for counting or something where there might be some calculation going on, then we would need to use one of several different numeric data types, either the integer, the double, or a special case called the Boolean. The first numeric data type that we used in our example was an integer, or rather int as we typed it out. And the integer data type will allow us to create variables that can store values between a negative 2 billion and a positive 2 billion. The next data type that we used was a double, which as you can see from the graphic allows you to create fairly large negative numbers to fairly large positive numbers. Also allows you to put up to 15 digits after the decimal point. The practical difference between the integer and the double is that the integer allows you to keep whole numbers and is used more frequently within your properties and settings and things of that nature than a double. Double allows you to store data that also has decimal places. Finally, we have demonstrated the use of the bool or boolean, and that allows you to keep values that are either true or false. So we're often using those in expressions, and we'll talk about expressions near the end of this lesson. Now there are a bunch of other data types that are available, but these four will help you get a long way as you're starting out. For those of you who are going to be computer science majors, you may need to know all, I think it's 12 or so, numeric data types that are available. But for those of us who are just average everyday programmers who just need to create applications that are usable, typically these four, and there's maybe 2 or 3 others that we might need to focus on, will get us just about everywhere where we need to go. Now the one thing we haven't talked about yet is that C# is a case-sensitive language, meaning that we can possibly do this. And even though these two variables are spelled exactly the same, by virtue of the fact that we used a capital V in value in the second variable declaration means that these are two different variables. So this can be pretty tricky. It can be a gotcha, and you should be very cognizant of what you're typing out. You need to be consistent and cautious whenever you're declaring and using variables that you create. Now the good news is that the code view will try to help you out as much as possible by correcting any capitalization mistakes that it can, but the bad news is that there might be situations where you're on your own, just like this situation, where you've declared two variables with very similar names. So the best advice is to always be aware of what you're typing and why you're typing it. Let's take a moment to talk about strings since we glossed over them just a moment ago. Whenever we type in a string like we did in the Hello World application, you remember we typed in the word Hello World in the message box and then we put quotation marks around them. Why did we use the quotation marks? Why do we do that? Well, it's really simple. It helps the C# compiler distinguish between a string literal versus a variable name. Well, we've already been talking about variable names, so the question is, what is a string literal? And it's basically any fixed set of numbers and letters that are arranged together that need to be displayed somehow. So here's one way to make the distinction. The variable is the bucket, and the string literal is what can go into the bucket. A string literal can be a message that we want to display to the user like we did in the Hello World application. It can be values that we want to save into a file or in a database. It could contain the file location that we want to save into, or it could be any other text that has some meaning within our application, whether to the user or to be saved off or whatever the case might be. So just for fun, let's consider this short example to make the distinction between the two. I'm going to create a variable called hello, and then I'm going to assign our variable, our bucket, called hello, equal to a literal string, hello. Then we'll do this. Okay, let's go ahead and comment out some of these lines of code here so we can just get rid of them. And I'm going to use my multi-line comment to do that we learned about in the previous lesson. And I'm going to run the application. Now what do you suppose will happen here? Well, we'll show two message boxes, and each one should say the word hello. There's the first one, and there's the second one. Now, what did we really accomplish here? That's a good question. The difference between these two message boxes is that the first message box uses a variable, and it will check in our computer's memory to see what is in the hello bucket. It happens to be the word hello. The second message box shows a string literal called hello. So if we were to change the first hello to store the value hello world, we would get a much different response. Hello world and hello. So hopefully that helps to make the distinction between a string literal, like all of the text that's in red here, hello world and the hello in our message box, versus the name of a variable, which is this first hello. So you might be wondering to yourself, why do you use variables? Well, simply put, it's so that we can save values off until we're ready to use them, or refer to them, or compare them, or evaluate them. And there might be a dozen other reasons. At this point, a simple example might help make a little bit more sense. First of all, let's comment out this little example. And then the next thing that I'm going to do is go back to my designer, and I'm going to add 2 text boxes onto my form. And here what I'm going to do is declare 2 variables. And then what I'm also going to do is come back here and let's put a label. And let's stretch this out. Well, I think it's auto stretch, so we'll be fine there. Okay, so now let's give this a try. Okay, notice what happened. Whenever I clicked the button event, it grabbed off the value from the first text box and the second text box and concatenated them together along with an empty space, which gave me the ability to put Bob and Tabor together onto the same label. Now, admittedly, this is still a fairly simple example, but we were able to store off values from our text boxes and then refer to them at some point in the future in order to display them back to the end user, or maybe we save them to a database, save them to a file, whatever the case might be. It's also available to us for processing, for making changes to it, and so on. Okay, so that's a pretty simple example, so let's move on. To paraphrase what we said earlier in this lesson, whenever you declare a variable, you're creating a space in memory that can hold a value of a certain data type. But what if you try to put a value into that variable that's the wrong data type? What's going to happen? For example, what if I were to do this? Let's comment out the rest of this. Notice whenever we try to run the application, Visual C# 2005 gives us an error, and it says, would you like to continue and run from the last successful build? We're going to select the No button because we don't want to run from the previous build. We want to run from this from the code base that we're currently working on. And the error list pops open, and notice that it gives us a description of the problems within our code. It found one error, and it says it cannot implicitly convert type string to integer. So it had a problem trying to convert the word Bob into a numeric value. Let's try the opposite. Let's do this. String equals 3. Once again, we get a problem. Cannot implicitly convert type int to string. Let's try another experiment as well. Let's go back to making this an integer, and then let's create a double. And let's see if that works. Okay, it compiles. We didn't really ask it to show us any output, but there were no problems whenever we ran the application. Now let's try the other possibility. And change this around, where we try to put 3.14 into our integer. Shouldn't accept it, but let's see what happens. Notice we get an exception. So the answer to our original question is not so easy. In some cases, the value will be implicitly converted to the correct data type, which simply means that the C# compiler will perform the conversion for you, so you don't even have to think about it. And that was the case previous to this one, where we had int my value equals 3, double my other value, and then we set my other value equal to integer. Since the number 3 could be converted implicitly into a double value without any problem, C# was able to take care of that for us. But in this case, where we have a double and we're trying to put that double value, 3.14, into an integer, C# croaked and said, we can't do this, there's a problem. Let me show you another example. We'll use our text boxes again that are on our form. All right, first of all, do you think this is going to work in the way that we have it typed in right now? Let's go ahead and run it and see what happens. Oh, we got several problems. Let's take a look at what the problems are. They all have to do with implicitly converting. The first two have a problem implicitly converting string, which is what is stored within a text property of a text box, into an integer, which is what we've declared the variable first text box as. The same can be true of this second line of code that we have here. The last line of code with the blue squiggly line underneath of it tells us that we can't implicitly convert an integer, which is the data type of our variable result, into a string, which again is what we would want to put into our label controls text property. So how do we rectify that? Well, we have to do some data conversion in order to make this happen. I'll explain what I'm doing in just a moment. Okay, what I've done is just called an explicit conversion, which means that you have to write the code to perform the data conversion. The C# compiler will not perform the conversion for you and will not allow you to compile and run the application until you write code just like this. Now, this is where things get tricky because this might not make a lot of sense at the moment. So just take what I'm about to say at face value, and later on in your learning you'll understand the why instead of what I'm about to show you, which is the how. If you want to convert a string value into a numeric value, you simply enclose the string variable or the string literal with one of the following, either like I've done here, int.parse, and then use parentheses around it. That will take whatever the string is and parse that string and try to make it into an integer value explicitly performing the conversion that you've requested. Now, if it can't perform the conversion, say for example somebody typed the word Bob in the text box, then you'll have a runtime exception. We'll talk about exceptions much later in this series of lessons. Now the second example, the one at the bottom, the result.toString. This will take some numeric value, whether it's a integer or double or a Boolean, and it will attempt to convert that value into a string. Now that should probably be more successful because the string's a little bit more liberal about what values can be inside of it. So this probably won't throw an exception no matter what you throw at it, for the most part. Now let me just say this, we used integer.parse or int.parse. We could also use double.parse or bool.parse, depending on what we're attempting to accomplish. Let's run our application. And we'll use this as a simple calculator where we'll add 3 plus 6 and we'll display the value. And you can see that it displays it as 9 in our label. Now if you'd like to learn more about how this works, the why behind what's going on here, you'll need to understand the difference between static and instant references to objects, which is a little more advanced, so I didn't want to get into that. We'll begin to cover objects and references in Lesson 6. So just hang in there, and perhaps this is going to make a little more sense as to why I use the .parse method or the .toString method in order to perform a conversion. At this point, I just recommend that you keep in mind that in order to perform a conversion, that you're going to need to use one of these methods, just like I did right here. Just for fun, let's go ahead and break our application like we said we would a moment ago. And here I'll type Bob, and here I'll type the number 6. So what we'll try to do is 6 plus Bob, and what we'll wind up getting is a big problem. And the nice thing about Visual C# 2005 Express Edition is that it will attempt to explain the exact nature of the problem. It'll say the input string wasn't in the correct format. It expected to find a value in the text box that could be easily converted into an integer value. Because we used int.parse, we would expect to see that value in there before we assigned it into our integer data typed variable called first text box. So we can read through the troubleshooting tips that we have here. We can look at the detail of the problem, or we can copy the exception detail to the clipboard if we want to post it on a forum or in a request for help from a friend or on a forums or whatever the case might be. So we're going to go ahead and close this down and stop the execution of the application. I just wanted to show you what that would look like. So at this point, we've written a very fragile application, and obviously we would need to do a little more checking, a little more validation before we attempted to do this data conversion of what's in a text box into a more restrictive data type that only accepts numeric values. Let's finish up this lesson with some terminology that we're going to need for the next lesson. Let me comment out some code here. Okay, here we go. Let's do this. Okay, now let's run our application to see if this works. And we get our problem trying to compile the application. Let's see what the problem is. In the error list, we get the message that only an assignment, call, increment, decrement, and new object expression can be used as a statement. So what does this mean? Why did we get this error whenever we try to compile the application? Well, the reason is because x plus 3 is not a statement, but rather it's an expression. In other words, it's only half of what C# needs in order to execute this line of code. Put another way, it doesn't really do anything. As we saw from the error in our error list, a valid statement can consist of some sort of assignment, like x equals 3, or a call, like messagebox.show hello world, which we use in our first example. It can be an increment or a decrement of the variable, like x plus plus or minus minus x, or it can be a new object expression, which we'll talk about in Lesson 6. So let's hold off on that one for a while. But as you can see here, we haven't done any of those. All we've done is just try to use x plus 3, but we didn't assign x plus 3 to anything. We didn't make a call to anything. We didn't increment or decrement anything in the manner which C# would have us to do it, although I guess we're implying here that we'd want to increment x by 3, but that's not the way we would do it. If we wanted to write that, we might do something more similar to this. But we didn't do that. That would be an assignment. We had this line of code. So as a rule of thumb, expressions can be evaluated. We can evaluate this expression and figure out what the value would be, but it's not a statement. Statements can be executed. So let's talk about expressions a little bit more. An expression can be evaluated. What does that really mean? Well, an evaluation is what you do with math problems. You evaluate the answer by either adding or subtracting or multiplying and dividing or operating the value in some way in order to determine the answer to the problem. And once you get the answer, you usually have to write it on your paper, or you have to raise your hand and tell the answer. Well, in this case, we're merely evaluating, but we don't write it down. We don't do anything with it. It's just out there by itself. Now, here's a good example. We didn't really go through it in very much depth earlier. Let's go back to this one right here. Okay. Specifically that last line, label1.text equals first text box plus an empty space plus second text box. Before, label1.text could be changed to the word Bob space Tabor, the C# compiler had to take the value from the first box, add it with a space, and then add it to whatever value was stored in the second text box value, which would have been Tabor. And once that evaluation took place, only then could it be assigned to the text property of our label. So this entire line is considered a statement because we evaluated and then we took the evaluation and assigned it to a property. If we were to just do this, however, on another line of code, that would only be an expression and it could not be used as a statement within C#. So let's go ahead and delete this and comment all this out. Now I wanted to make this point about evaluating expressions because it's something that we'll be using quite a bit in the next lesson on branching and iteration statements. In those cases, we're going to be doing a different sort of evaluation. We're going to be evaluating to see whether an expression evaluates to be true or false. So just as a quick warm-up to the next lesson, let's go through a few examples. First of all, is 3 less than 2, true or false? Well, that is obviously false. 3 is not less than 2. Let's switch it around. Is 3 greater than 2, true or false? Well, that expression rather, is true. Okay, let's go on to the next one. Given that integer x equals 3, x equals 3, true or false? Well, that is true. Now let me explain some of the operators that are being used here. A single equal sign is used for assignment. A double equal sign is used for evaluation. Another way to think about it is that a single equal sign is used for telling. I am telling x to store the value 3. A double equal sign is used for asking. I'm asking whether or not the value of x equals 3. Okay, so just keep in mind that in C#, unlike other programming languages, there are different operators used for assignment and evaluation. Okay, one last one. Given that x is equal to 4, is x not equal to 3, true or false? Well, that would obviously be true. And just to explain the operator that's used here, the exclamation point combined with the equal sign evaluates to not equals. So in that case, the answer is true. 4 is not equal to 3. Okay, so we learned about a couple of new operators that we can use to evaluate an expression. And now you're ready to move on to the next lesson and apply some of this newfound knowledge to branching and iteration statements. If you enjoyed watching this video, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one aimed at all skill levels on many different topics related to C#, Visual Basic.net, ASP.net, and more. Thank you.